Hello everyone, I would like to thank and welcome you all to the East Shea Corridor Area Drainage Master Study virtual public meeting. To start off, let me introduce myself. My name is Lana Nabati and I'm the Flood Control District of Maricopa County Project Manager. Also, we have Brian Schaap with us from the consultant team, and he is the consultant project manager. Before we begin, please note that the virtual public presentation and comment period are now available from May 10th to May 20th. On this slide, we have the meeting agenda. During this virtual meeting, I will introduce you to the project partners and I will give you some feedback about the East Shea Corridor study. I will talk about the Flood Control District of Maricopa County's goals and mission and how that is achieved. In my presentation, I will go over the project's goal and objectives. Also, I will cover what has been completed to date and the next steps to complete the study. Brian will be talking about the major tasks, hydrology and hydraulic analysis effort, and the project schedule. The East Shea Corridor Area Drainage Master Study is a regional drainage study that is conducted by the Flood Control District of Maricopa County in partnership with the City of Scottsdale, the City of Phoenix, and the Town of Paradise Valley. From the City of Scottsdale, we have Ashley Koch with us, Ray Dovelina from the City of Phoenix, Paul Mood from the Town of Paradise Valley, and last but not least, Brian Schaap from Holistic Engineering and Land Management. What is the Flood Control District of Maricopa County? Even though Maricopa County is in a desert, floods occur during two distinct rainy seasons, the summer monsoon and frontal winter rains. Although the Flood Control District has made significant progress over the years, work remains to be done. Maricopa County continues to be one of the fastest growing counties in the United States, with over 200 people moving here every day. What are the district goals? Our primary goal is to reduce flood risk for existing and future residents in the community and the county. So how do we do this? The district studies watersheds throughout Maricopa County to identify the locations and intensity of flood hazards and risks. This is done by evaluating the existing flood hazards, floodplain, and risk, and through conducting public outreach to inform the residents and community leaders about the types of flood hazards and risks that can occur from moderate to large storms. Then we develop alternatives and solutions to mitigate the flood hazards and reduce flood risk. Here are some of the project's background and goals. This study is one of the many regional drainage studies the district conducts to protect existing and future development from possible flood damage during large storms. The East Shea Corridor Area Drainage Master Study is a restudy of a portion of the 1978 Paradise Valley Scottsdale Phoenix study, which covered 64 square miles. In 2000, approximately 9.2 square miles of the Paradise Valley Scottsdale Phoenix study was restudied as part of the Scottsdale Road Corridor Drainage Master Plan. The study area is approximately 51 square miles located within the City of Scottsdale, the Town of Paradise Valley, and the City of Phoenix. As you see on the map, the study area is bound by Loop 101 in the north and the Salt River Pima-Maricopa Indian Community in the south, and the McDowell Mountains in the east, and the 64th Street in the west. So why are we doing this study? The district decided to prioritize this study for the following reasons. This watershed has not been studied for more than 20 years. New development has occurred within this watershed. Also, new technologies are available to create more accurate mapping, hydrology, and hydraulic analysis. The Flood Control District and the City of Scottsdale have received so many complaints stating homes and infrastructure in the study area has experienced flooding and drainage problems. Additionally, awareness of flood hazards and risk can help residents reduce risk of injury death, and property damage. The project goals are to identify flooding drainage problem areas that will be classified to high and low hazard zones. The classification will be based on the depth of the flow, velocity, the multiplier depth times velocity, and the historical flooding drainage problem zone. To create usable and useful regional hydrologic and hydraulic model, and to be a dependable resource for others to use. To perform a realistic flood hazard assessment. Just because the model shows there is a flooding problem does not mean there is an actual problem. Therefore, the consultant performs the model validation by looking to all the historical flooding observation and field assessment, and also by looking to all the high water marks and so forth. Our ultimate goal is to keep the community safe. Therefore, we will review and revise the FEMA designated flood zones as necessary to better define the flood risk. Then we will develop solutions to mitigate the flood hazards and reduce the flood risk. We will have a full day brainstorming session to come up with ideas and solutions for flood mitigation plan. I will go over what has been completed to date and the project's next steps. The consultant collected and reviewed all the flooding complaints that were received from the City of Scottsdale, the town of Paradise Valley, and the City of Phoenix. And we met with the stakeholders to gather more data about all the known problem areas. They also created a comprehensive database of critical information, including known flooding and drainage areas. The consultant collected all the data related to the existing and new infrastructures within the study boundary as well. As the district has several rain and stream gauges in this area, the consultant reviewed all the data and used them for the hydrologic and hydraulic analysis. We have completed initial stakeholder coordination, base flow 2D model or base flood hazard modeling, and much of the data collection efforts. The next steps are to finalize the flood hazard modeling and assess the flood hazard risk to structures, properties, and public infrastructures. The team will review and evaluate all the data that will be collected at this public meeting. Also, the team will share the study results with the public after completion of the modeling and flood hazard identification effort. This will be done by conducting additional public outreach to inform residents and community leaders about the types of flood hazards and risks that can occur. We will develop high-level recommended solutions to mitigate flood hazards for the identified flood-prone areas, and the recommended solutions can be deployed by local government, community associations, and residents in the future. We will evaluate the FEMA flood plains within this watershed for potential to delineate the existing one. Community input is a key element of this project. As I mentioned earlier, the district is coordinating closely with the project partners and stakeholders. Please get involved and provide any flooding photos and videos that you might have. Also, you can provide your input by filling out an online survey and visiting the project website, or going to the district's website and report a flood through the district's report a flood tool, or simply just contact me. On the slide you have my contact information, and please feel free to contact me if you have any questions. And with that, I will hand the floor to Brian Schock. Thank you.
Hello everyone, my name is Brian Schock and I'm with Holistic Engineering and Land Management. So I'm going to give you an overview of the study, an overview of the modeling results, and kind of go over the big picture schedule for this project. So let me start by giving you an overview of the general or primary tasks for this particular project. And those include data collection, hydrologic and hydraulic modeling, public outreach and stakeholder coordination, flood hazard assessment and prioritization, and strategic planning of future flood hazard mitigation efforts. So to start with data collection, this is a task that of course started right away at the beginning of the project and will last throughout the duration of the project. As part of the data collection effort, we look to collect things like as-built information for existing drainage facilities such as culverts and storm drains. We also collect and look at previous studies so we understand what was done in the past and what kind of findings came out of those studies. And also, really important, we go out and we collect information from the public, such as drainage complaint areas or nuisance flooding areas. We look to get input from you as part of this data collection effort. The hydrologic and hydraulic modeling task is, of course, another primary task for this project. Let me just say that the approach we're using for the hydrologic and hydraulic modeling is a two-dimensional modeling approach. So I will be talking about this particular two-dimensional modeling approach in later slides, but let me just say right now that this type of modeling is widely used and accepted by the Flood Control District of Maricopa County, as well as other agencies and communities, just not in Arizona, but across the Southwest and across the U.S. As I mentioned before, outreach and stakeholder coordination is very important for the project, which is why we're reaching out to you today through this virtual public outreach presentation. We use your information to help us validate our hydrologic and hydraulic models. And so we use your input to help us make sure that where drainage complaints or drainage issues are arising, that our models reflect that. We want our models to reflect the existing conditions out in the real world as best as possible. And so stakeholder coordination has been ongoing, and it includes reaching out to the major stakeholders such as the City of Phoenix, the City of Scottsdale, City of Paradise Valley, as well as major utilities such as the Central Arizona Project. Flood hazard assessment and prioritization is done once we have everything, all the pieces of the puzzle put together. So we've collected all the relevant data, we've gotten input from the public, and the hydrologic and hydraulic modeling is finally complete. Once we have all these pieces of the puzzle together, we can assess flood hazards and flood risks and start to prioritize the different areas of concern. And then, once we have areas of concern prioritized, we can use all the information to make strategic, informed decisions about how to best address flood hazard mitigation. So, for example, it may be beneficial for new mapping of flood hazards and flood risks, or certain areas may benefit more from new drainage facilities such as storm drains, culverts, or channels. Or maybe certain areas would benefit most by additional outreach, providing more information on how you can help protect yourself from flooding in the future. So those are the overall tasks for the study. The flood modeling approach, or hydrologic and hydraulic modeling approach that we're using for this particular project, is a two-dimensional modeling approach. The software that we're using is Flow2D. The two-dimensional modeling approach has advantages because it is able to estimate flow in multiple directions, as compared to a one-dimensional model, which is able to estimate flow in just one direction. So for example, one-dimensional flow would be flow confined within a channel, whereas flow is moving one direction, that is downstream. Two-dimensional model is able to estimate flow in multiple directions. For example, as flow is conveyed down a major arterial street, as this flow approaches a roadway intersection, a portion of the flow can go straight through the intersection, or a portion of the flow may go to the left, or a portion of the flow may go to the right. The two-dimensional model is able to estimate how much flow and what direction this flow will go. So a Flow 2D model is built using a grid comprised of square elements. So if you could imagine our study area being overlaid with a sheet of grid paper, and each one of those grids measures 15 feet by 15 feet. So approximately 6.3 million grid elements are required for the development of our model. Now within each one of these square grid elements, as you can see as an example in this figure, information, both input information is provided and output information is obtained. So input information such as how much rain, the intensity of the rain, soils, land use, roughness characteristics, the information necessary to determine how much runoff will be moving across the study area from one grid element, for example, to another grid element. Now, because we are providing input every 15 feet across the entire study area, we are also provided output information from this model every 15 feet across the entire study area. Output information such as flow depth within a cell or a grid element, flow velocity within a grid element, water surface elevation within a grid element, and the magnitude, or how much flow actually crosses that grid element. So there's a lot of detailed information that goes into the model, but we get a lot of detailed information coming out of the model. Now, in addition to everything that gets input into each one of these square grid elements, the model is also able to incorporate other drainage features such as bridges or culverts, buildings, and property walls, because features like that, of course, divert flow and can impound flow. We can also put in one-dimensional channels like this, and of course we can also include storm drains, so flow actually below ground, it's not on the surface. And so the two-dimensional modeling approach is a widely used and accepted modeling approach. The Flood Control District of Maricopa County uses it quite a bit, as well as other agencies and flood control districts across the Southwest and across the country. So in the previous slide, I gave you an overview of the two-dimensional modeling approach we're using for this particular study. And what we have in this slide is an overview of what the modeling results look like across the entire study area. So if you remember the study area, which is outlined here in blue along the CAP Canal and west of 64th Street, coming up and around, bordering with the Salt River Pima-Maricopa Indian community, and then the top of the watershed being the McDowell Mountains. So this particular study area, again, is 51 square miles in size. Grid elements measuring 15 feet by 15 feet were used to construct the two-dimensional model, and that was approximately 6.3 million grid elements. So what type of information do we get then every 15 feet across the entire study area? We get information such as this, which is flow depth, maximum flow depth. The maximum flow depth that you're seeing here in the different shades of color, which are highlighted over here, which is a key to the color and the associated maximum flow depth across the entire study area. So you can see that in areas where there is broad, shallow, unconfined sheet flow, where the flow is not very deep, it's probably this light blue, orange, pink color. And then flow where you would expect it to be deep, such as ponding against the CAP and these flood control facilities, along certain channel features, such as this channel feature coming out of the McDowell Mountains, you can see it's a darker shade of green or purple because there's more flow there, more flow depth. So again, this is a type of information that we can get from this two-dimensional modeling approach across the entire study area. And so we'll take a look at this particular, these modeling results, these maximum flow depths in a little more detail over the next few slides. So in the previous slide, we were looking at Flow 2D, two-dimensional modeling, results, maximum flow depths for the 100-year, 24-hour storm across the entire study area. So it was at a very high elevation or altitude. We were kind of looking at it in a very broad scale. But if you were to zoom in to a particular area, so for example, in the vicinity of Cactus Road and Scottsdale Road, you can start to see what the modeling results look like. And so as you can see, we have these maximum flow depths again for the 100-year, 24-hour storm. And you can see the key over here. And so the different shades of color and the corresponding maximum flow depth for that color. You can see broad, shallow, unconfined sheet flow in certain areas where the flow isn't that deep, and so it's probably less than a foot deep. Whereas compared to some of these darker colors, maybe the flow being, as you can see, conveyed down streets or within drainage facilities. So you are probably familiar with Cactus Park. It was designed and constructed as a flood control facility to capture storm water to help protect residents and properties downstream of Cactus Park. And so again, just wanted to show you an example of the type of information that this two-dimensional modeling approach provides us. Now we use that information in conjunction with other information such as reported drainage issues. And so what you have here, these dark circles are areas where a reported drainage issue has been provided. And so again, what we do is we take the modeling results and we take information that is provided by the community and the stakeholders. We take information that is provided from previous studies, and then we compile it and merge it all together so that at the end of the project we can make informed decisions about what to do next. This slide is showing an area in the vicinity of Shea Boulevard and Hayden Road. Again, we are looking at the 100-year, 24-hour maximum flow depths. And again, you can see that this two-dimensional modeling approach that we're using does a really good job of capturing flow down roads, within flood control facilities, such as this facility, which meters flow into a channel, where you would expect to see more flow or higher depths of flow, which is why you have the darker shades here. Again, this is the key that shows you what color and the color and the corresponding maximum flow depth. So you can see that we have broad shallow sheet flow in some areas, a lot of roadway flow, but also shown again are the reported drainage issues, these darker circles. And so again, it's important for you to provide input to us for this particular study, because what we like to do is use your information, such as reported drainage issues, to help us with the modeling. So for example, if we have a lot of reported drainage issues in a particular area, however, the modeling results don't show very significant flooding in that area, maybe the modeling needs to be adjusted in order to actually reflect better the existing conditions out there. So again, you can see flow being attenuated or captured in the golf courses, flow within channels, flow down streets. So this slide is showing an area in the vicinity of Thunderbird Road in 84th Street. This is Northside Park here, the 101 over here. And again, what we're looking at are the 100-year, 24-hour maximum flow depths in this area that is being provided from the two-dimensional modeling every 15 feet. Also shown are areas where there have been reported drainage issues. Again, important to correlate these reported drainage issue areas with the actual modeling results. Again, we'd like to make sure that the modeling results are reflecting the existing conditions. And one way we do that is by comparing it to the input we get from you. So you can see that the model does a really good job at showing ponded flow in these facilities in Northside Park. It does a great job of capturing the roadway runoff, so you can see flow within the roads. And you can see areas where potential ponding is taking place this in parking lots or maybe behind a property wall. So this slide is showing an area in the vicinity of Shea Boulevard and 104th Street. So what I want to point out in this slide, again, we're looking at the 100-year, 24-hour maximum flow depths, the different shades of flow depth and the corresponding depth of flow. And I want to point out that the modeling results that we've been looking at are preliminary. So this is preliminary hydrologic and hydraulic modeling. The flooding extents, the depths of flow are potentially going to change based on the amount of detail that goes into the model. And so as we progress through the project and the modeling becomes more detailed and we're able to validate the model based on information that we get from you and from gauge records, then we're able to have a better reflection of the existing conditions. And so you can see in this particular slide the different types of drainage characteristics that we've been talking about: broad, shallow, unconfined flow in certain areas where, of course, you would expect to see reported drainage issues. We also see flow that is being captured and conveyed within channels, such as this channel along here and this East Via Linda channel, where the flow depths, of course, are deeper because there's just more of a concentration of flow, and so you see these darker shades of color. So again, this is just an example of the level of detail that the two-dimensional modeling approach is providing us. Again, information, these flow depths are provided every 15 feet across the entire study area. This particular slide is showing an area in the vicinity of East Via Linda and North 136th Street. And again, just want to point out some of the drainage characteristics throughout the study area. And so what you don't see to the north and upstream here is the McDowell Mountains and the Mountain Preserve, where, of course, the top of the watershed where a lot of this flow and the runoff comes from. And that flow comes from the Mountain Preserve and is captured through these large channels that cut through these neighborhoods. And you can see that because the flow is concentrated within these channels, and these reflect somewhat of a natural wash corridor, you can see that the flow is concentrated within these channels. The flow is deeper, which again is what you see in the key. Again, the different shades of flow depth and the corresponding depth of flow. And so you can see again flow captured within the channels coming out of the Mountain Preserve and down through the neighborhoods through these channels. And so again, the model results provided every 15 feet capture a lot of good details, such as the roadway flooding which you can see right through here. So now that you have an understanding of what the project entails and what some of the modeling results look like and why we're reaching out to you to get your input, let's just do a quick little overview of the remaining study schedule. So let me also say that these studies are very large and very detailed, and so they can take quite a long time to actually complete. And that's also because there's a lot of interaction with the public and with stakeholders. It depends on available funding from year to year. But again, they're big studies, and so they can take a while to complete. And so as I mentioned before, the modeling results that we were showing in the previous slides are preliminary hydrologic and hydraulic modeling results. And so currently we are in the process, and this summer we are doing preliminary modeling and building those preliminary modeling and adding detail as the models are reviewed and checked by the Flood Control District of Maricopa County. So we're going to continue to build the preliminary models as well as reach out to the public and stakeholders to get your input so we can down the road use that input to help us make sure that our models reflect best the existing conditions that are out there, and also use your input to make informed strategic decisions down the road. So once we have the preliminary modeling done, we'll start to get into the more detailed modeling where we'll actually be validating the modeling. And so the validation process means that we'll be looking at your input and gauge records to make sure that extents and flood depths match what we're seeing out in the real world. So as they say, the devil is in the details, and so we'll be doing that over the summer of 2022. And then once we have the models completed, the detailed models completed, and we have compiled all the information we've obtained from the public and stakeholders and previous studies, we can start to then identify flood hazards and flood risks. So we'll compile this information and identify these areas of primary concern. And then we'll come back out to you, out to the public, and we'll present the results and our findings, and we'll get feedback from you to, again, help us make the best decision as in moving what to do next moving forward, whether it be new, better, more detailed flood hazard mapping, design and construction of new flood control facilities such as storm drainage channels or basins, or maybe more outreach to help provide you more information on how you can help protect yourself from flooding. So let me just say that this presentation is going to be available online between May 10th and May 20th. So please provide us your input. We're looking forward to hearing from you, and it's very important that we get as much input as we can from the public. So I want to thank everybody for watching this presentation. Again, it's going to be available between May 10th and May 20th. So earlier in the slides, we provided you, or we showed different ways that you can provide your input. So Lana Nabati, again, is the project manager, and this is her contact information. And you can always get information about the project by going to maricopa.gov/East Shea Corridor. So again, I would like to urge you to definitely provide your input because it is important. Again, we're going to use your input to help validate the modeling that we're doing for the study area, as well as use your input when we're making decisions down the road. Okay, I appreciate the opportunity that I had to give you an overview of the project, the different tasks that we're doing, and give you an overview of what the preliminary hydrologic and hydraulic modeling results look like. Thank you very much for your time. I know everybody is busy, and if you have any questions, definitely reach out. Thank you.